And welcome back, AP Calc students. Time for more free response questions from old AP exams. Today we're looking at AP Calc exam AB from the year 2016, and we're looking at question number 5. So question number 5 is similar to questions earlier in the year when you had a conical tank that was leaking or being filled up, and it was very similar to the related rates type question. Similar, but a little bit different because of the this container is not perfectly conical, but let's look at it and we'll see if we can pick through this. It says the inside of a funnel, so a funnel isn't technically a conical tank. Funnels have a different curvature. But the inside of a funnel of a height of 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r is equal to 1/20th 3 plus h squared. So I just want to write that equation down over here. So the radius is equal to 1/20th times 3 plus h squared. Okay? And the tank is, or the funnel is 10 feet, 10 units high. I guess it's in inches, it says. 10 inches high. So that's kind of all we have. And again, you can see the shape here. It's not quite like when we would have, when we had the conical tanks, if you remember, a cone, that would be the volume was equal to 1/3 pi r squared h. Well, this is a little bit different style, and you can see the cone being curved, or the funnel being curved, is a little bit different. But there's still kind of a related rates aspect to this. So let's see what we have here and see what we can do. So question A says, find the average value of the radius of the funnel. Well, this is just a quick review over here. You always want to remember whenever you hear average value in calculus, and I'm just going to say the average value of a function. So the average value of f is always equal to an integral over an interval. So it's 1 over b minus a times the integral of f of x from a to b. So the average value of f, you're going to have to integrate it over an interval and then multiply it by one fraction of the difference, or the fraction of the interval, which is 1 over the difference of b and a. That is always going to give you average value. I don't care what they're talking about. You just average value of, fill in the blank. This is going to be your process. So for A says find the average value of the radius. Well, there's our equation right there. And so we can just say, well, the average value, and it does say in the question, it says 0 less than or equal to h less than or equal to 10 for the inches. So we could say, well, b minus a, that's going to be 1/10. And then we're going to integrate from 0 to 10 this function. So the function here is 1/20th 3 plus h squared dh. Put that down a little bit lower. Okay, so that would be average value. Now, since this is question number 5, it is a non-calculator, so the expectation would be you could navigate this this little integral here. So let's take the 1/20th out front. And this will just be a little bit of integral manipulation here. So we have 1/200th out front. So from 0 to 10 of 3 plus h squared dh. And that's pretty friendly to integrate here. So we've got 1/200th times the integral of 3 is going to be 3h, and the integral of h squared is going to be h cubed over 3. And we're going to evaluate that from 0 to 10. Okay? So let's see what we get here. We get 1/200th times, looks like we get 30, plus we're going to have 1,000 over 3, minus, if we put in 0, that all zeros out, times 1/200th at 0. So depending on the question, how much time do you want to spend with this? If we distribute the 1/200th, that's not too bad. So if we distribute that in there, we would wind up with 3 over 20, and then we distribute this in there. We'll have plus, and we'll knock off 2 zeros, and then we can cancel the, well, we'll cancel the 200 with the 10,000 and get 5. And so we would have, excuse me, we would have 5/3. And I guess we could get a common denominator of 60. And all this is just extra arithmetic here. So what do we get here? 20 over 20. And this becomes 3 over 3. And so we get 9 plus 100. And looks like we would get 109 over 60. And this is inches. Okay? So I guess if you wanted, you could have left it back here, but I guess we can go all the way through and get a common denominator. So it's a little less than 1.5 inches. So that's the average value of the radius. Okay? And in fact, if you want to look at it, think of it this way. If you were at when the height is 0, if we're down here at the bottom, the radius is only 3/20. And when h is 10, that's going to be 100 plus 3. 103 over 20 would be the radius there. So 103 over 20 is a little more than 5. So the radius is, on the average, is about 1.5. At its maximum, a little more than 5. At its smallest, it's 3/20. So that seems reasonable. Okay. Now let's look at part B. Part B says find the volume of the tunnel. Now, if this is the 2020 exam, volume is not going to be on there. But just for the setup, this actually isn't that bad of a problem because you're going to be integrating from the bottom to the top, and you're just going to be integrating whatever the formula is for the radius, or for the cross section here. So I'm not going to solve it, but I'm just going to set it up just to put it here. So if we were integrating from bottom to top, we would say, well, we're integrating from 0 to 10, and then I need the formula for what one of those cross sections would be. And if you think about it, the cross section, it says here, circular cross sections. Well, we would have an infinite number of circles, and that's just pi r squared. So if pi r squared is our the area, I'm going to put the pi out front, and I'm going to put the radius in here, which again is 1/20, 3 plus h squared. So that is the radius, and that's squared dh. That would actually give you the volume. We don't need to worry about it, but I just want to put that there. It's a little cumbersome on some of the arithmetic here, but that's what you would have. But not a worry for the 2020 test. So let's move on to part C. Part C says the funnel contains liquid that's draining out the bottom. So that should kind of remind you of the leaky conical tank. At the instant when the height of the liquid is at 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So this is the best part of the question that has to do with related rates. And again, probably the best part of the question, in my opinion here. So what I want to do is just look at the relationship that we were given. So I'm going to write that down here again. And I think after you look at it, it'll become a little more intuitive here. So we have r is equal to 1/20, 3 plus h squared. So again, we have radius information in relationship to the height. But I want to read the question again and pause here. So it says the funnel contains liquid draining from the bottom at the instant when the height of the liquid is 3. Okay, so I'm just going to write that. When h is equal to 3 inches. Now remember, this thing's only 10 inches high, so we're getting toward the bottom third here. The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. So the radius is decreasing at a rate of. If the radius is decreasing at a rate of, they're giving us dr dt. They're saying the radius is decreasing at a rate of 1/5. And since it's decreasing, it's negative 1/5. And that was inches per second. So I'm just jotting that down. So if you think back to doing the 5-step method with related rates, it's not that sophisticated a question. It's just a specific term here. And then the rest of the question says, at this instant, what is the rate of change of the height? So what they're asking for is the rate of change of the height. Well, they're just asking for dh dt. Okay? So they're telling us h, they're giving us dr dt, and they're asking for dh dt. So a lot of students overcomplicate this question. It's actually really pretty easy. So the first thing you want to do, just to make life simple here, is distribute your 1/20 in here. So we would get r is equal to 3/20 plus, and I'm just going to leave it as 1/20 h squared. And then what we're going to do with this is we're going to take d dt of it. So this is kind of like the related rates where we'd say after you have your equation, take d dt of it. So the derivative of r is 1, variables don't match. I have dr dt is equal to the derivative of 3/20, 0. The derivative of 1/20 h squared, 2 times 1/20 is 1/10. H to the first, but my variables didn't match, so I have dh dt. This is the key to the question, is just correctly deriving that. And then it's just a matter of substituting. They told us h was 3, we'll put that in there. They told us dr dt was negative 1/5. So this is negative 1/5 is equal to, h is 3, so this is 3/10, and we're solving for dh dt. Multiply both sides by 10/3, and I get 10/3 times negative 1/5 is equal to my dh dt. Cross cancel there, and I get negative 2/3 inches per second is equal to dh dt. So this is the kind of question that actually, after you take a little time and look at it, it's actually pretty easy, but it's intimidating the way it's written, and a lot of students get scared away. Some of the fear just comes from the wording, but it's not bad at all. And so really, for the 2020 test, you really just want to be focused on average value. Just make sure you're always getting average value down. Don't confuse it with average rate of change. And then just once you have an equation with a relationship, taking ddt of it, getting down here, not bad. And the volume, not a concern for this year. So that is AP Calc AB 2016, question number 5, parts A and C. Thanks for watching. We will see you next time.